Good afternoon, welcome to my laboratory. I've been getting behind here on reporting. I've got so many different gadgets that I haven't yet reported on. So I'm just going to go through a bunch of them right quick like. Let's see. First, let's start out with this. This is just a CR2032 battery in a holder. It's a 3-volt button cell, and I've been using it for demonstrations for a while. And let's see here. I guess I'll start with this. Okay, this is the mini pulse motor that I've described before. Right now, see that over there? Right now, what I want to do is demonstrate it operating in the pure reed switch mode. That right there is a little reed relay that I have mounted in just the sweet spot, and a biasing magnet here, so that the rotor is actually able to use the reed switch inside the reed relay, not using the relay coils at all, just the reed switch in the normal way to make a reed switch pulse motor. So there's the this part of the circuit over here is not in the circuit right now. There's the DC input. It just makes a circuit through the reed switch and then back to the negative of the DC. But across the contacts of the reed switch, I also have a fast diode going to a capacitor and a neon bulb, Ne2 neon bulb there. Okay, so that's the spike recycling system and the output of the high voltage to the neon bulb. So, and then those two little drive coils I've described before. Okay, and that's the whole thing there. So I'm going to plug in that little battery now. If I can get it on the whole thing all at once. There. And give it a little spin to start. And I think you can see that the neon starts flashing. And not only that, but this little guy over here, this one, sometimes wants to spin in sympathy with that one. Okay, so what this is here, this is one of those little generator things out of the light faucet powered, water powered generator. And I took it, see there it goes, in sympathy with that one. So I took it and rewound it with heavier wire and then mounted it to this little reed switch circuit. This is a Hall effect sensor switching a transistor circuit to make another kind of a little pulse motor. And so let's see, let's plug it in and give it a little starting spin. And it runs quite well on the 3 volts from this battery. This was all working towards researching the Lars Crow looper circuit. Okay, anyway, there's that works. And then this is a sort of a mini Slayer kind of a thing. It has an oscillator, self-oscillating circuit made with a 2N3055 transistor, and then this is a Tesla bifilar 8-turn primary circuit, and then about 400 turns of wire on there, and then here's a little neon dangling. And let's see if I can plug in. It runs on 12 volts, and the loop stick brings it into really precise tuning resonance. You can see that the capacitor, the neon is glowing, and then I've got a little, little RF coming off of there, and then of course the tuned loop stick receiver picks up the EM power radiated off of that, and it makes the LEDs glow quite well. Okay, and let's see here. This is the newest gadget. This is a 2SK170 transistor, a blue LED, and a resistor on the gate of that little FET. So if I give it the power, What I have now is an electrostatic field detector, and right now it's picking up the field coming off that TKSlayer exciter there. And it will also pick up and respond to the field of a charged piece of plastic, like that. It's a neat little thing to play with. And then this thing here, this is the interesting low voltage circuit, low voltage jewel thief, and it sits here and it charges up the capacitor from the ambient room lighting. But when it does that, it needs to be kind of kicked into oscillation. Let's see if I can do this just with a little stroke of a wire across there. No, it doesn't have enough charge on it. If I charge it up with a little bit of light from a flashlight, and then give it a little stroke across the LEDs, it still doesn't want to light up. Is it affected by the field of the Tesla coil thing? Yeah, that was what it was. I had the Slayer exciter on, and it was somehow damping out the ability of this thing to start oscillating. But as you can see now, it's going. That's interesting. All right, that's 7 minutes of current project reporting from the laboratory of Tinsel Koala. Thank you for watching.